Welcome back, everybody, to the VW ID Talk podcast. We are your hosts, Jan and Wes. Thank you all so much for subscribing. It really means a lot to us and makes us want to do these things like we are doing today.
Headphones holder?
Okay. What this has to do with cars is that I have complained often that I don't have the skills to design some of the parts that you have designed. And so you decided to make something that was made from simple shapes.
Yeah.
Where you could do a demonstration and show people how to build their own parts for 3D printing to solve problems the way Jan has.
Yeah.
But the point is not the headphone holder. The point is learning how to make the headphone holder.
Yes.
And that's how it relates back to the ID Talk podcast.
Yes.
When you want to design something like this, what do you start with? I mean, I'm looking here at a 3D CAD modeling software.
Yes. So the first thing that I would start, even before I go into this, is I would measure my headphones.
Okay.
Right? So I would just measure the size of the thing that I want to create.
And for something simple like this, how long is it taking you to design this?
I would say 5 to 10 minutes.
Yeah. Okay. So if you have measurements, and that sounds pretty old school, but you use calipers, you use a ruler, you're measuring things.
I do have calipers. Calipers is the most important thing.
Okay.
And when I design something a little bit more complex, so for example, the design for the 4-window switches was, I've used two things. You can take a photo of that 2D element and then trace it in the Fusion 360.
Okay.
That's the 3D software that I'm using for modeling. And then, of course, in combination with calipers, I transferred all the correct shapes into the right places and literally designed the element from scratch.
You're able to take a photograph and overlay it on your CAD, import the photograph into your CAD software, and then size it to the point to where you know it would be the size of the actual real physical object and trace over it to create your object.
So I have a great example here. Let me guess if you know what it is. Okay. So guess what this is.
I do know what that is. Okay, so that is the screen removed from your ID.4.
That is correct. That is correct.
And you have the buttons from the Skoda ENIAC attached to the bottom
below that,
so that you could line that up on a grid and measure to help you determine exactly how big the things. And even with this, even if you get it right, millimeter accurate, you're still going to have to change things. This is much more complicated to design something for this than it was for you to design a headphone holder.
There's one important thing that I realized is that when you're taking the photo of an object, the camera has to be perfectly parallel with the object, because if it's at an angle, then there is a distortion, and then one part, the left part, let's say, would come bigger than the right part. So just like taking the photo isn't easy, but also you see that I've taken it with a ruler, and when you import it into Fusion 360, you just say how much is 29 centimeters, and you literally swipe it and it will scale this to the right size. So that relatively was simple.
Very cool. Okay. Why can I not use something like one of those otter scanners from Creality and just scan the thing I want to make and then print it? Is that...
Well, I guess you could, right? The question then comes is, can you print that directly, or would you need to trace it in the 3D space?
And I think that is the answer, is that they don't have it to where it doesn't output in a format to where it can be directly printed. So I think that's what you'd have to do, is take that object, import it into your software and trace, and theoretically should be more accurate than your photograph, but you still have to do the work of tracing it and then making a 3D object for it.
Yes.
Okay.
100%. So this is how I started for the screen.
You're going to show us how to make it from a completely blank slate, how to make this headphone holder that you're holding. So the basic workflow, though, is you open up a CAD modeling software. I've done some tutorials in FreeCAD. This is Fusion 360, which is made by Autodesk, the folks that make AutoCAD, and it's free for personal use.
Yes.
Mm-hmm. Okay.
So if you want to sell those models, you need to license. If you want to give them back to the community on MakerWorld, Thingiverse, then you can use the free version. So how do you design, because your monitor is 2D space, and so how do you design a 3D object in 2D space? I'll just hit this create button, which is create sketch. Okay. So that allows me to choose the right plane. And by the way, I am not a professional in Fusion 360, and there are multiple ways of doing things. So if you think that we are doing something wrong and there is a way to do it better, please comment down below.
Always good to learn.
So the first thing that I would like to start with is the base.
Okay.
Right? And so I've measured the width of my headphones, and this was 180 millimeters. So what I'll do, I'll just click this center diameter circle, and I'll just align it with the center, click, and then drag my mouse, and I said 180. And the beauty is that you can you see that there is a dimension inside of the circle, so you can start typing 180, enter, boom, done, right? 180, cool. Then there is another portion, which is the stud, or the portion that holds these headphones. And so I again measured the width of the headphone, and that was 80 millimeters. And then from the width perspective, I somehow designed it so it's like not too wide open, but
you want it to have some pressure, a slight bit of pressure against the headphone cushions, without stretching it too much. But if it's not enough, then it's just going to slide off. Okay,
yes, exactly.
I see.
Exactly.
And that you had to make an executive decision on how much pressure you want.
Yes, okay. And of course you can then test the first print, and if it doesn't work, you can go back and align it. Okay. So for what I want to do here as a next step, I'll create a rectangle, but this time a center rectangle, meaning I would like to start drawing that rectangle from the midpoint here as well, right? So regardless how I slide, it always is centered on the same center as the circle, right?
Okay.
Beautiful. So it's 60, and I'll press tab, and 80, enter, done. So now when you look at it, we have the base. If you look at it from the top, we have the base and we have the rectangle, right? Yeah, but we have not erected these dimensions up.
Okay. So it's just a plane sitting on top of a plane. I see.
Yes. So now this was more like an executive decision, how the base should be thick or tall. And I decided it's 40 millimeters, right? So this is 40 millimeters. And then the height of the holder, of course, I still wanted to have some small clearance below the headphones, but I also didn't want to exceed the size of the printer, so I still would need to be able to print this.
Yes, so that's maybe 20 millimeters difference between the height of the. Okay.
So let me go back into the sketch again, and let's switch. Thank you, and I'll hit Finish Sketch.
Okay.
And then these areas, you see that they are separate and they're separately selectable.
Okay.
So I'll select the outer space and press E for extract. So or extrude. I'm sorry. So you can also press S for search, and then you can search for extrude command here.
Okay.
But what is really cool is that those keyboard shortcuts, when you select the area that you want to extrude, you just press E for extrude, and we know that this is 40 millimeters, right?
Yeah. So you're taking something that's drawn in 2 dimensions and extruding it into 3 dimensions, bringing it from flat up to. Okay, that makes sense. And I can see your rectangle in the middle. Okay.
Okay, and we have exactly. The next thing that I want to extrude is the middle column. So I'll go back to the sketch and click on the inside, press E for extrude, and say 245.
Now, the extrusion from your rectangle, is that coming from the top of is that what you were about to say? From the top?
It's coming from the bottom.
From the bottom, okay.
Mm-hmm. So that's why I needed to add those 40 millimeters of the base.
Right? I see, okay.
Now, here is another very important thing that I do that mistake all the time, which is now when I hit OK, and then as we look at the number of bodies, you see that we have 2 bodies here, body 1 and body 2. Okay. Because when I extruded it, I said that the operation is new body, not joining. So if you double click on the extrusion here, I'll say join and OK. Beautiful. Okay. So now you see it's one body. So now it would behave as one element. The next step, let's make this, I would say that it's called fillet. So And
Okay.
there are multiple ways to do this. This is how I chosen to do it. You can, of course, do this little this arch on the top differently. But what I would do here is that I would apply a fillet, so-called fillet, to
Okay.
the top edge to get a round edge here. And the simple thing is that it's right here, fillet. You can, of course, press search, S for search. So search and then fillet. And then you select these two edges, boom, boom, and now you can make them round,
All right. Okay.
right?
And you can
And I
decide
think
how round, how much you want.
how round it is. So maybe you just want to make them boxy, right? Like this doesn't have to be round. It could be like more boxy like this. It's just totally up to you how you
Yeah.
think that the design would pop the most.
Okay. Yeah. It's just aesthetic at this point. Okay. But for
Exactly.
some
So
designs, it might be important to have it be curved a certain way to fit another part. Or okay.
yes. So I usually always add some tiny fillet because the edge looks nicer. It's not that sharp edge, right? All right.
Okay.
Fillet done. Okay, great. So now we have kind of like this base shape. What we might be missing here is you see that all these edges have a fillet on them as well. So everything is nice and round.
Every single
right?
edge. Okay.
And so some people again may choose to do that after, because what we need to do, we need to make this hole in the middle, right?
Yeah. Okay.
So I would like, so again, let us know down in comments if you would do it differently. But the way how I would do it is maybe add the fillet now. So I'll add a smaller fillet to these surfaces. So I'll add a fillet to,
and you can define the radius of it in millimeters, right?
yes, and
radius.
you can go and define like how round it is. And if you overdo it, meaning hey, the fillet cannot be drawn, it will throw an error. Right?
Okay.
So I think that for this one, my executive decision was let's do 5 millimeters. All right, so we are almost there, right? Now the only thing is that we need to make this hole.
Okay.
And
like a negative space. Okay.
Like a negative space, exactly. And the reason why, again, you don't have to. If you like it like this, done, right? But what I wanted to show you is how you could make the hole and create something in another dimension, because we are now working from in one dimension, but the hole is in another dimension, right?
I see. Okay.
So what I would do, I would create another sketch, but this sketch won't be aligned to these axes. But you can add sketch to any surface.
Okay.
So I'll add a sketch to this surface. Boom, done. So we have a surface here.
Okay.
And there are multiple different ways how we can do this. The way how I would elect to do this is that I'd create a circle. I think I said like 40, 42. Then if you press M, you can move any object. M for move. And I would just eyeball it so that I want to align it roughly like this. So I need to either press enter or hit OK. So now the move is finished. So I can say Control C, Control V. And now I have a second instance of that circle. And now you could make again, your executive decision as you're designing this, like how far down I want to have this bottom extrusion. Do I want to do it just like halfway or kind of like aligned with the headphones, or like how far do I want to go? So now I have two holes, right? So what we need to do, because we want to connect these edges so that we can extrude that we can do negative extrusion in that space. I think the easiest way here again would be just do a rectangle, and as you're moving, you see that the X sign snaps to the previous geometry, right? So it just snaps to the circle, and then I can snap it here. Yeah,
and we're still sketching in 2 dimensions here.
Yes, we are still sketching in these 2 dimensions. And then if I finish the sketch, you can select this negative space, right? Press E for extrude again, but this time we are going the negative way inside. And if you cut to the inside, you see that this operation is, because it knows that there is some object, so it automatically flipped to cut.
Okay. So you're cutting instead of extruding. Okay.
Extract and cut. All right. There we
It's
go.
okay if you
right?
go farther than you don't have to go exactly the length of your design. If you just went way farther.
Oh, I went just beyond that because
okay.
Yeah,
Doesn't matter.
Because then you decide, oh, I want to make this center column wider, right? And then if you go back to this first design and say, well, this I actually changing my mind. This should be 100 millimeters, right? Then when you come back, you see that this entire thing re-rendered.
Oh, cool.
Right. So that's what I love, this like parametric design or parametric feature, that it automatically kind of recalculates the entire model. And so
Cool.
that was perfect when you're designing those small window switches, right? If you want to go back to the beginning, you still can.
Yeah. So parametric meaning it designs the physical object based on the parameter numbers that you've given it.
That is correct, yes. And it's kind of rendering it live.
Okay.
Now, this could be good enough, but if you want to apply the fillet also to the inside, to the extrusion that we have just done, you can either create another fillet and apply it here, or what you can do is on your timeline, you see the fillet 2. So I can take it and grab it all the way to the end. Now, you can go back, double click this to be back in the edit mode. And if you press select, now with a control key, I can select additional surface. So I select this and the same from the end.
Okay.
And so this is another typical error that happens to me, but the fix is really easy. This error is telling you that the fillet cannot be created because the amount of the curvage is too much, meaning you cannot create a fillet over fillet. So the easiest workaround is to make the fillet smaller, right?
Okay.
So in this
because
case,
you mean if the thing is only 8 millimeters thick, you can't put a 5
millimeter exactly. Yeah,
or they overlap. Okay.
But if this is good enough, if this is exactly what you wanted, now you need to export this and import this into the slicer. So okay. I usually like to rename the things, right? So that's like, let's go headphone holder.
Okay.
And then if you right click this, you can see save as a mesh.
Okay.
And I'll just export this.
And a mesh is like an STL, a stereo
and
lithography
it's exactly
file.
Okay. An STL or EMF file. You can export either format that you want.
And for the people that are not 3D printer people, a slicer is a program. Mm-hmm. This one, he has a Bambu 3D printer, so Jan's using the Bambu Slicer. But if you think about 3D printing, where it builds the thing in layers, each layer is a slice of the model. And so you have to put your model in here and tell it how it's going to build those layers. That's what slicing software does. It gives instructions to the printer of how each layer is built. And you can see that Jan pulled this in and it turned it on its side.
So you can either press the auto align, or you can just select which edge to sit it on, right?
Okay.
That's it. So now technically they should be ready for printing. So you can choose some important features, like, of course, what printer, what filament you can use. I just selected this PLA matte red. Then that's pretty much all you need.
And so for some objects you design, you're going to want to orient them such that they're the fewest number of overhangs, things that you don't have to build support materials out in thin air. Exactly. But this is probably the most efficient way to build this part, right?
Yes. Yeah. So this, if you make this top thin enough, believe it or no, it does not need supports. It just prints like this without supports.
Wow. Okay.
And then when you press slice here, it would calculate the tool path, or what layers and how many layers does the printer need to print, right, of this material. And you see this is 1200 layers. And when you scroll down, you see how each layer is being printed. And so you're saying, oh, this will take almost half of a spool, because spool is typically 1 kilogram. So this would take half of a spool. What you can play with different infills, so-called strength. and you maybe say that, oh, there is too much filament here. You see that the mesh is these holes are very tiny. Maybe let's change it to 10% infill. And if I reslice it, you see that these holes are now bigger, right? And then voila, we need almost 100 grams of filament less to print this.
And so
and of
those
course, it would
holes,
be faster.
it's like the honeycomb inside of the base, this used for support. It's not.
Yeah,
I think
it's
maybe
the internal structure.
some
Yeah,
people might look at your model and think that that base is going to be one big solid chunk of plastic. It's not
yeah,
solid
which
plastic.
is not, because
So
that would be a lot of filament,
yeah,
right?
so the
Like
infill is
you can
yeah.
potentially you can
Okay.
you can like simulate this, right? Like it's kind of interesting how many kilos this would be. Oh, this would be like 2 spools, 2.8 kilos of
Wow.
filament if this would be solid.
Okay, I see. But so that would just be a waste of filament. So you have to
Yes.
determine
Yeah.
based on how strong the part needs to be, how much
Yes.
infill, how
Yes.
big or small the
Yes.
honeycombs that support on the inside
Yes.
are. Okay.
And there are different different infills that are maybe even structurally better than the honeycomb.
Hmm.
But what I also like to play with are these wall loops, and it's just a technicality. But like one interesting thing is that when you look at the slice here, then
Hmm.
you see that the wall layer is constructed of two layers, right? You
Okay.
see one and two.
The
Now,
outside layer. Yeah.
if
Hmm.
I want to say that, oh, I need that stronger, which probably would not be the case for this, you can say four. And if you reslice it, you would see that it would come back with 4 layers now. See, 1, 2, 3, 4.
Okay. And that doesn't change the dimensions of what you've made at all. It's just changing
No,
how
no.
many layers of the how many
Yeah, because
layers solid the
those
yeah.
are added to the inside of the object, but the
I see.
object is inherently stronger, of course.
Okay.
And then you would like send it to your printer.
All right.
And then the printer prints it like layer by layer, exactly as how you defined, right? And once it's done, after a couple hours,
Yeah.
it's done. You can let it cool off, and you have then a new cool gadget to rest your headphones on.
I love it. So in the time that we've been sitting here doing this, you have gone from the concept to designing a part to printing it. And well, we didn't watch you print it. We did a time
Yeah,
lapse.
that would take 6 hours. So that's
Yes.
probably like you can send it and print it overnight or something, or while you're out in the house. But yeah, that's
That'll be on our new lo-fi channel that we release where where you can watch the 3D printer. So cool, Jan. Thank you, man. That's really neat.
yeah.
So now what's your excuse, subscribers, for not making your own parts? Well, you don't have one. You got
Exactly. So now you can come up and design some parts, and you can help us redesign some parts, like for the window switches, or if there's some other retrofit that you really want to do, but you could not, or you didn't want to. So now you know how to get started. And I literally learned how to use Fusion 360 um, on this exact part. So this was my very first part that I've designed in Fusion 360. That's the cover for the display. That was my
really.
first ever Fusion 360 design. So
Well,
you
that's
can get started
even more
anytime.
impressive. Even more impressive. That's amazing. Is
And
that part?
so then what we've shown you today, how you can use, for example, Fusion 360 to build this headphones holder. Then we exported it as a mesh, so we can import it to our slicer for the printer, Bambu, Prusa, whatever other printer you have, and then send it for print, and then enjoy your new creation.
Absolutely wonderful. I love it. Well, thank you so much. Thanks everybody for watching this, and thank you for subscribing. It makes it more fun to do stuff like this when we know people are excited about it. Please let us know in the comments if you have any tips for improving things, and we'll post places where you can make your own parts and list them on the parts sites for free for other people to use. We'll see you next time.
See you next time. Thank you.